Welcome to Royal Mechanical. Welcome to a free internship for mechanical engineers. In this internship, you learn how to design a press tool using CATIA V5. I will explain how to write an internship report for this course in this video. I am sure you have created the 3D and 2D of the press tool for your assignment component using CAD software by now. Let me remind you again, you can design the press tool using any CAD software. Once you have the 3D and 2D of the press tool ready, the next step is to prepare the internship report. I am providing you with two documents. One is the sample report. The sample report is the report which you can refer to prepare your internship report. The other is the template report. You must update the template report with your assignment design calculations and images. The link to download both reports is available in the description box of this video. The first page is the title page. First, enter your name. Then insert images of the press tool assembly, die assembly, and punch assembly in their respective places. The second page is about the company. You don't have to change anything on this page. The third page is the placeholder to insert the internship certificate. You can insert the internship certificate once your report is approved by me, and you can download the internship certificate. Page 4 is about the objective of the internship. As you know, this free online internship for mechanical engineers aims to teach CATIA V5 and design press tool using CATIA V5. On this page, insert the image of the assignment component. Page 5 is about the CATIA V5. You don't have to change anything on this page. Page 6 briefly explains the press and press tool. You don't have to change anything on this page. Page 7 briefly explains the blanking operation. You don't have to change anything on this page. Page 8 briefly explains the cutting clearance. You don't have to change anything on this page. Page 9 briefly explains the design process. You don't have to change anything on this page. Page 10 is the heading of the chapter, Design of Blanking Die. You don't have to change anything on this page. Page 11 is about understanding the requirements. Insert the image of the assignment component drawing. Page 12 is about the part material. The part material is the same, so you don't have to change anything on this page. Page 13 is about the part material thickness. The part material thickness is the same, so you don't have to change anything on this page. Page 14 briefly explains the strip layout design process. You don't have to change anything on this page. Page 15 briefly explains the raw material availability. The raw material is the same, so you don't have to change anything on this page. Page 16 is to calculate the punch and die dimensions. Enter the design calculations. Page 17 is to calculate the edge and feed bridge dimensions. Insert the images of the component being sheared when raw material is slit along the length and width. Don't forget to indicate the feed bridge dimensions in the image. Page 18, insert the images of the component being sheared when raw material is slit along the length and width. Don't forget to indicate the edge bridge dimensions in the image. Page 19. Enter the design calculations to calculate the pitch when the raw material is slit along the length and width. Insert the images of the component being sheared when raw material is slit along the length and width. Don't forget to indicate pitch dimensions in the image. Page 20. Enter all the design calculations related to material utilization. Page 21. Complete the design calculations related to material utilization. Page 22. Insert strip layout drawing. Page 23 is the heading of the chapter force and tonnage calculations. You don't have to change anything on this page. On page 24, insert the component perimeter calculations drawing. Also enter the design calculations related to component perimeter. Page 25, enter the design calculations related to calculate shear force calculations. Page 26, enter the design calculations related to calculate tonnage calculations. Page 27 is a brief introduction to press selection and specifications. You don't have to change anything on this page. Page 28 is the drawing of press bolster drawing. You don't have to change anything on this page. Page 29 is the drawing of the press adapter plate. You don't have to change anything on this page. Page 30 is a brief introduction to detail design. You don't have to change anything on this page. Page 31. Enter the design calculations related to die plate thickness. Also, insert the image of the die plate. Page 32. Insert the image of the locator pin. Page 33. Insert the image of strip guide plates and strip support plate. On page 34, enter the design calculations related to strip weight. Page 35. Enter the design calculations related to push force and spring length. On page 36, enter the design calculations related to spring constant and maximum spring deflection. On page 37, enter the spring selection from standard catalog details. Also, insert the image of the strip pusher. On page 38, insert the image of the die back plate. On page 39, insert the image of die shoe. On page 40, enter the design calculations related to the transition slenderness ratio of the guide pillar. On page 41, enter the design calculations related to the cross-section area, the moment of inertia, and the radius of gyration of the guide pillar. On page 42, enter the design calculations related to the slenderness ratio, critical buckling stress, and critical buckling load of the guide pillar. On page 43, enter the design calculations related to the actual load of the guide pillar. Also, insert the image of the guide pillar. On page 44, insert the image of the stroke-in block. On page 45, insert the image of lifting hooks. Page 46, insert the image of the screws and dowels of the die assembly. On page 47, insert the image of blanking punch. On page 48, enter the design calculations related to the stripping force and stripper plate thickness. On page 49, enter the design calculations related to the push force, stripper stroke, and spring total length of the stripper plate. On page 50, enter the design calculations related to the spring constant and spring maximum deflection of the stripper plate. On page 51, enter the details of the spring selection. Also, insert the image of stripper plate, stripper springs, and shoulder bolts. On page 52, insert the image of the punch holder. On page 53, insert the image of the punch back plate. On page 54, insert the image of the top plate. On page 55, insert the image of guide bush. On page 56, insert the image of the punch assembly lifting hooks. On page 57, insert the image of screws and dowels for punch assembly. Page 58, the heading of the chapter, Manufacturing Drawings. You don't have to change anything on this page. On page 59, insert the image of the assembly drawing with the title block, balloons, and bill of material. On page 60, insert the image of the assembly drawing with the title block, balloons, and bill of material. So, that's the end of the internship report. All the best. Happy learning.